on.
Okay, so just to remind everybody, our objective is really to enable the citation of large numbers of papers, software, data sets, research objects, by providing a means of collapsing them into a single reference or a small number of references, or ways that we can reference a large number of things efficiently. Of course, now I've lost my focus again. And we also want that projects and different other collection means are available so that you can bring those research objects together and actually call them a thing, right? That is combined together, and group those things. I mean, we have lots of reasons to do that in science. This is something we've all been trying to do in different means. So we also want to empower individuals to be able to create these things. This shouldn't just be something that repositories and large group projects can do. It should be individuals, and provide the ability to cite the thing or subsets of that thing. And so we introduced in the first one this name Reliquary as just a placeholder for what we're going to call this thing, because it was like the only name we could think of that hadn't already been used by somebody for their grouping of things. So starting assumptions in this, the near term, that we're going to assume that the limits on references in the main paper for a lot of these publications were going to remain in place. We realize that many people object to that, but that doesn't change that publishers, at least some of them, will keep it. That it's important to enable citation of individual objects, and that citations of research objects and groups need to be countable. That we want that's a really important element of all of this, that part of the reason for citations is to give credit back to those authors. If the authors can't figure out that they were cited, it's not very useful. So credit is important to them. And it's unlikely that one solution is going to address all use cases. So we're trying to figure out what are the primary solutions that could be put in place, that could be adopted by broadly across the spectrum, where publishers, authors of different objects, repositories could all be looking at implementing the elements of this, and the citation tracking folks. So what did we propose as parts of the Reliquary? That they're organized around a theme or whatever you want, actually. That they have a unique identifier and well-defined citation components, so that the object itself, this Reliquary, can be cited. But that each object in the Reliquary also has a unique identifier that could be used as part of a citation. That it has descriptive metadata, each of those objects in it, that the type and role of those objects are well defined, so that they can be recognizable. That the Reliquary could appear in the reference section, and each citation of the Reliquary individually could be cited or as the whole Reliquary. That the Reliquary can contain objects of many sources and repositories, that they're not always just from the same place. That tracking of credit is possible for both elements within the Reliquary and the Reliquary, and that access to the object in the Reliquary can be accomplished from a description of that, basically from that citation. And that all objects in the Reliquary have machine readable definitions, ideally, since we're all trying to move toward being much more interoperable and machine readable. And with that, that's the whole intro to sort of what did we talk about last time in our 90 minutes? Because the rest of what we talked about is what are some of the pieces of solving this problem? And what's out there already? What are things people are already attempting in order to try to solve this problem? What are pieces that may or may not be in use now, but may be good parts of the solution? So the rest of the time just talking is going to be some talks from some of the folks who have pieces of that. So we're going to start with some of these use cases, and then we're going to move to some of the infrastructure elements. I asked to all the speakers that you try as hard as you can to keep them short. I'm going to limit everybody to the time limits so that we can get some discussion time in. So please bear with me if I tell you you've got to stop, because I really want to keep everybody to their time. So without further ado, I want to turn it over to Carol to tell us about RO crates. Carol, all yours. Carol, I think you're muted.
Sorry about that. I'm on mute because I'm coughing so much. Okay, so packaging and describing data collections. So why would we want to crate up objects, research object crates? Well, because you heard from Deb, things are done in parts with associated objects, but those parts are linked but together by their context. So they're related to each other, but those parts are scattered across different repositories, and within different repositories there may be different data sets, but within the same repository they're made at different times by different people. So we've got parts and we've got flows. We need to move things across multiple platforms, across different multiple researchers, across different infrastructures. So we exchange. And we also want to be able to exchange references to objects, but without moving the objects. So that means big or sensitive data or active content. So that meant that we worked hard on a packaging solution. So this is, RO Crate is actually a practical lightweight packaging approach to put together data entities, that's the technical term, but in fact it's any referenceable object with metadata. So what that means is that you can aggregate into a citable RO Crate files, any URI addressable content, another RO Crate, along with contextual information about it. And that packaged content will be scattered and can be scattered across multiple different repositories or different data sets. And that means effectively what it's doing is it's creating a self-described integrated view that spans over these fragmented resources by relying on identifiers and metadata. So the RO Crate, the crate itself is citable and the content within it is citable. It's infrastructure independent in the sense that it's not tied to any one particular platform, and we use it in projects to exchange packages of data and references to data between repositories and registries, and also to point to things that we don't want to move. So in a nutshell, and I won't go into the details of this, it's basically a way of organizing a metadata file with some content, and the content can be a file or a directory of data, which can also point to other data, file and objects, links to web resources, and links to contextual entities, that is things like ORCID or RAW or Creative Commons. So it has a very linked data approach. It uses standard web technologies, so it uses standard identifiers, JSON-LD and schema.org, and Baggit and other off-the-shelf formats. So you get this machine and human readable and actionable metadata, but it's developer friendly. And things are typed by profiles, that is assertions about what you expect to see there and what the schema.org markup is around those objects, with extensions to other domain ontologies. And that's really important here because you need to honor legacy and diverse data sets and to deal with all the unknown unknowns when you're trying to describe your content. So at the bottom we have a little example of a profile. Where it's used, for example, in data repositories. Here it's used in this paradesic data repositories, both to describe the central repository, but also for regional repositories to move their content across their collections and into this central repository. It's used in the specimen data refinery that's part of a biodiversity project in Europe. where it's used in two places to describe the bare digital object, which represents the physical specimen, here a pinned insect, and also the pipeline that you need in order to be able to process and digitize that. And the bottom shows a sort of example of what one of these objects looks like. And we also use it in some data spaces for Earth science projects and some data storage and sharing fabric projects, where the work is to do with putting into extending Zenodo to support this approach. And this is a brief slide in order to be able to get across the fact that RO-Crate is currently being used in Earth Sciences, where their profile extends to including data cubes, which are collections projects that are very widely used in Earth Sciences. So, but I don't have time to go into the details of that because Deb will be really chasing me. So where does this fit with data citation use cases? Well, it intrinsically has been designed to handle collections of data sets and to point to aggregated references. So it's all that's been designed in. And to hold metadata, even if the original repositories or the things referenced to are no longer there. We've actually already implemented this approach in something called big data bags, which is processing large clinical data held in multiple locations, where actually what you're just dealing with is bags of pointers. You're not dealing with the actual data itself because you don't want to move that data around. So we already have extensive experience of that. And RO-Crates have been designed to contain other RO-Crates and describe them with as little or as much as been needed. We also have a way of representing an RO-Crate as a repository object, which I've pointed a link there. So this is really my last meaty slide, which is taking Deb's examples. We see two perspectives of this as a packaging mechanism for data citation. One is an aggregator of data sets, citations, where the simplest case is everything's beautifully described. The data that you're trying to cite together is beautifully described with DOIs and all the metadata needed. And that's really straightforward example. But then there are more complicated examples where the world is not that well behaved, where you have just random collections of data files that haven't got the citation, haven't been given a DOI, or how do you aggregate the citation records themselves? How do you deal with many citations of different types? And so here, this slide is trying to lay out how you would go about dealing with those kinds of use cases. And then there's also the use case, which is, it's not an aggregator of dataset citations, it's a citable dataset of datasets, where the ad hoc datasets have not been published with DOIs, and really you're making the RO-Crate is becoming the citable object to pull them all together. And there are subclasses of those as well, to do with how one packages together links to remote files, uses checksums and metadata in the crate, and then you can pull on demand the objects into the crate in order to be able to process the content. But I've only got 8 minutes, so I haven't got all the chance to go through all the details, but you will have all the slides. The important message here is not everything will be described beautifully with DOIs. In fact, most of stuff isn't. It's actually done in a very kind of rough and ready way, and local references, local identifiers will still live, still prevail, I'm afraid, unless Martin gets his way. So, so we have to be able to deal with not just the perfect case, but all of these other kinds of cases. And then this is my final slide about, we have this notion of an RO-Crate repository collection and repository object that represents the records in a repository that we use when we're supporting our data repositories and RO-Crate export from digital repositories. And
thank you so much, Carol.
This is the end. Did I make my 8 minutes, Deb? And now I'm going to.
Okay, thanks so much. So we're going to save questions for the end and for the chat. So Carol, you already have some questions in the chat. Please answer them there. And we're
Okay.
going to go on to Yugis, who is going to tell us about biostudies.
So Deb, we have a slight change in our agenda. Paolo can't stay and has his talk queued up. If he,
Okay.
it would be okay. Okay.
Yes.
Thank
Perfect. Thank you.
Thank you for this, and really apologies. Well, I can stay, but not as long, not after 6. So that would actually be a problem for the presentation I have to give. Wait a second, because I picked the wrong one. Can you hear me fine?
Yes.
Okay,
Yeah.
cool. And the slides?
Yes.
Cool. Okay, so thank you again for this change in the agenda, and thanks, Carol, for your introduction, because I will actually mention something that is very related to what you have just presented. So first of all, let me contextualize the work that I'm going to present. This is the result of a working group under the RDA, so the Research Data Alliance in Europe. And the basic problem there that we wanted to address was how to share information about linking data and articles over the web and across the scholarly communication. So the problem here is that we have so many disconnected sources, including publishers, data centers, repositories, and on the other hand, we have so many different practices, so different PEAT systems, as I mentioned here, different ways of referencing data and different universes, because the publisher are actually very different and sometimes too far away from the data centers where we deposit our data. So the idea behind what we call Scholix was to have everybody sitting at the table, taking simple decisions, pragmatic decisions on how to exchange these links for the benefits of all the stakeholders in the scholarly communication. So if before we had a scenario like the one on the left, where the individual data sources were establishing bilateral agreements and connections and interoperability issues one by one, namely Elsevier, for example, had to deal with a plethora of different data repositories out there to exchange this kind of information, so explicitly links between articles and datasets. Today, they can exploit this common format that we came up with, common implementations, common libraries, and we can also group these links based on hubs, what we call hubs. For example, Crossref is now collecting and publishing via Scholix links between articles and datasets, while DataCite is doing the other way around, and OpenAir is doing the same thing on the side of institutional repositories, where many times these links are being preserved. So what is Scholix about? Is basically an information model for links representation plus recommendations and provisions for the exchange formats. So it follows the FAIR principles because we're kind of standardizing, therefore making it simpler to reconstruct the original experiment, describing and finding in an easier way the description of the data sets that we're publishing thanks to the publications and so on. So of course it's going towards interoperability and reproducibility as well, okay? So we published these documents in Zenodo, so you can easily find them there, okay? So the simple information model and the properties, we are talking here about a record that describes a source objects and the target objects, and the target object and how these are related with the relationship, whose semantics can be specified, can be of a specific vocabulary. But the point is that we are making it minimal, and what is mandatory is very minimal. And it's the ability of having persistent identifiers of any kind, which we can resolve at some point. So the idea of providing title, publisher, creators is actually to simplify the process of reusing of these links. Otherwise, you can reificate, let's say, their current status by resolving the provided identifiers. Of course, the benefits are multiple. I'm not going into the details of this, but data repositories and journal publishers find it easy because they can, as long as they publish something, find immediately the links to the related data sets and vice versa. You can rebuild graphs of relationships and build aggregations like the one we have in OpenAir. you can easily exchange the information across different sources. So that's good for all of us, right? For monitoring, statistics, navigation for discoverability, etc. So here is an example that we could mention and is related to today's workshop. So we have a publication who's citing a list of publications, and these publications in turn are supplemented by or cite datasets they have used or they have produced. And the datasets themselves have links between them. Okay, all this is possible to be described thanks to Scholix. So you can export a list of relationships, each of them describing the relations between these objects. These objects can have any persistent identifiers they want. And so we can represent this full graph and send it somewhere thanks to the linking and build our relationships. Now, the reliquaries that we are discussing, or whatever they will be called after this workshop, there are somehow ways to collect a list of citations. So you can imagine, for example, a publication pointing to a reliquary, which in turn gathers, that's the verb I'm using here, but of course that's just a suggestion, a number of objects that are cited by the publication itself. And these objects may vary, right, in number, even after or before the publication, because the publication only needs to preserve the link to the reliquary itself. So this could be changed, modified, and can be, let's say, pointed, because it's an object with its own dignity and a persistent identifier. So it's part now of this graph. And of course, you can point to it or point from it using any Scholix relationship, as long as reliquaries become part of this vocabulary of sources of research products or research entities. Now, if you take the arrow crate example, which is one example of packaging things, that goes even a little bit beyond, because the arrow crate, you can see the arrow crate as, first of all, an object on its own, with its own metadata, which is M1, described here by M1. And the objects embeds inside the possible connections between a set of related objects, okay? So in this case, we actually put into the arrow crate the whole graph that I was exemplifying in the previous picture. So the as has part, the mentions, these are all relationships that describe the graph internally to the research objects. So you can, thanks to the fact that you know how these relationships are specified, depending on your context and so on, take a research object and do something with it. Okay, so you can access the research objects with its own methodology, methods, and system. At the same time, the research objects, it's an object itself with its own metadata, which can be, again, part of the Scholix frameworks as part of the citation. What is interesting here is that the graph that I mentioned before is out there, let's say, rolled out with its own original relationships and navigable relationships, but without a context anyway. So you can still browse the original graph of P1, P2, P3, D1, and P3, following the relationships. But those relationships were not forming a context or a scope, a unified view, which is now wrapped up thanks to the arrow crate. In this case, this gives a tremendous added value, because conceptually we are wrapping with meaning all these objects and provide them as a whole, you know, to the rest of the community. And of course, being an existing methodology, you can use it to describe a reliquary as well, which is one of the possible customization of an arrow crate. Now, the last 3 slides is just to mention the fact that thanks to Scholix, of course, we are now able to exchange these links. And so we built a service as part of the OpenAIRE battery of services called Scholexplorer. I put these slides here because people tend to confuse the two, right? Scholix is a standard, Scholexplorer is a service, completely different things. We build a very large graph of relationship between data sets and articles, with the idea of now extending it to software and to links between articles. When we collect these links from a variety of data sources, but especially from the hubs that I mentioned before, so Crossref on the one hand, DataCite and OpenAIRE. When we collect this link, we resolve them. So we want the original records as well, and we harmonize them. So we tend to put them in a common model, and we deduplicate them. So if the same object comes in with different persistent identifiers, we put these things together with all types of PIDs. And then we publish the links. So we have open APIs through which you can, given a persistent identifier, resolve to all the related objects, okay? And of course, can be extended to any objects, including reliquaries in the future. So given a reliquary, you would be able, by sending a simple request to the APIs, to resolve it to all the objects it contains, like the list. And that happens dynamically. Okay, so if the reliquary changes, of course, as a consequence, you will get different replies accordingly. So we export everything via Scholix, and it's free at the point of use, so you can actually use it today. This is just to mention what I just, to picture what I just explained. So we collect content from Scholix APIs, from the hubs, from sources, and we export them to several services, including Scopus, including various data repositories and institutional repositories. I'm just mentioning a part of this here. And we publish the content through data dumps for those who want to run research or implement services like Scopus.
So Paolo?
I'm done. It's this is the very last slide. Just to show the growth, this is what we have today. So thank you very much. Again, open for questions.
Thank you, Paolo. So I asked that people put questions in the chat, and it sounds like Paolo can stay on for a little while, so he'll be able to answer them.
I'll be here.
So unless we've changed the order again, I'm going to go back to Yugis.
Okay, thanks. Yeah. I will share the screen now. Okay. Can you see this? Yeah. Okay. So yeah, hi, I'm Ujis Sarkans from the European Bioinformatics Institute near Cambridge, UK, which is a part of EMBL, a larger organization. We build a number of data, bioinformatics and life sciences data resources, and biostudies is one of those data resources. So I have just a couple of sort of general slides sort of introducing what biostudies is. Well, the problem that we are trying to solve with biostudies is the data heterogeneity in life sciences. Well, of course, the data is heterogeneous not only in life sciences, but I think in life sciences there is a long-standing culture of sharing data. And for example, the protein PDB, the protein structure database, recently celebrated the 50th birthday, and the sequence databases have existed for 30 and more years. So there is a large number of various structured community databases for specific data types, but there are more and more studies that generate different data types, different what we would call omics data types, and therefore entries associated to the same publication are scattered in multiple community databases, and this is one of the use cases that biostudies tries to help with. There are also other use cases listed here, so data that does not have a well-defined structure, or perhaps a community that is only emerging, and standards are associated standards are also only being built. So these are other cases for biostudies use, but that's probably a bit less relevant for today's discussion. So that's a graphical representation of the biostudies information model, which is very generic. We tend to talk about data packages. So a data package may be associated to a single publication, or perhaps to a unit of work in a larger project. And the data package may include the data files that do not have anywhere else to go, like in this diagram, the metadata, of course, and then links to resources either within EBI or external. So these are just names of different EBI and specialized community resources, and the link to the publication. So some of the principles, as I mentioned, the very generic underlying data model that can work across these quite different use cases. and then services typical for a range of life sciences data repositories for data upload, downloads, metadata capture, a concept of data collection, which is that can be sort of configured for a specific purpose, for data acquisition and data distribution purposes. So that's sort of a very rough introduction to biostudies. But then, well, talking about sort of the problem that is being discussed here today. Well, life sciences in general has a long-standing history of using compact identifiers, and so these are just 3 sentences extracted from this publication. Well, the publication is not the most recent; it's sort of more than 10 years old, but the situation would be the same also today. So these are data citations essentially, where there are 120 or so different data objects that were generated, but then they are cited in this sort of human readable but not very machine readable way. This is actually an example of an error of where the data was deposited, because this accession number does not match the database. And the third point just illustrates that there are various types of links between the paper and the data set. So essentially, yes, we have to work with compact identifiers more than with, for example, DOIs. And then the data capture tool, this is just a screenshot of BioStudies data capture tool, actually makes it easier to enter and to capture compact identifiers. We use a service also built at EBI called identifiers.org, which is a central registry of various life sciences compact identifiers, and defines for each of the identifier types how this can be resolved to a URL. This is just a screenshot from today. There are 733 different types of compact identifiers as of this morning. So yeah, so I think the point here is to what I wanted to stress is that I think we will need to work with compact identifiers for a long time to come, and they are very important for life sciences. And this is perhaps also just an admission that, well, biostudies is about 5 years old, but we are only assigning DOIs sort of on demand, and well, we get more and more requests for DOIs, but it's sort of not a universal thing. And we will implement quite soon the approach of Zenodo, where individual versions of a record get their own DOIs, as well as the entire collection of versions has its own DOI. So this is really my final slide. Then I think that the credit, sort of this transitive credit assignment problem has been already discussed at length during the previous meeting, and it's not something where we can offer any possible solutions. I think we would be one of the first, perhaps early adopters of any recommendations in this area. So if this data package is cited, how does the credit to the individual components within the data package are captured? And then the second point here is really about the impact, sort of. So citations of that data sets, it's of course very important, but there are other well, impact measures possible. For example, our colleagues at OmicsDI, which is again a resource at EBI that captures omics data sets from indexes omics data sets from a number of resources. So they have offered this list of impact metrics in the field of life sciences or omics data, and so of course, yeah, number of downloads and views, and the second and third are perhaps self-explanatory. and number 1 and number 4 are perhaps more specific for life sciences field, but perhaps not necessarily. So that's all I had, and yeah, thanks for inviting me. Very interested in this area.
Thank you, Yuki. And you win the prize so far for hitting your timing perfect. So next up is Daniel.
All right, can everybody see my slides?
Yes.
Perfect, thank you. Okay, so my name is Daniel. I work for GBIF, the Global Biodiversity Information Facility, and I'm here to talk a bit about our approach to data collections, how to cite them, and the solutions that we've chosen to make sure that everything is fair and that contributors to GBIF receive the credit that they deserve. So I'll just start off with a super brief introduction to GBIF to those of you who might not be familiar with the organization. GBIF is an international network and data infrastructure funded by the world's government aimed at providing anyone, anywhere, open access to data about all types of life on Earth. GBIF is also a massive database of currently more than 1.7 billion records of organisms occurring at a specific time and specific location, originating from more than 36,000 different data sets. This data is used or was used and cited in more than 1,000 scientific publications in 2020, and these numbers increase by about 30% every year. So when users download data from GBIF, and they do so at a rate of more than 80 billion records per month, it's often based on searches for specific taxonomic, geographic, or temporal focus, not so much which data set or which data publisher that data comes from. So for example, we could have a researcher interested in frogs occurring in springtime in Mexico. Once the user then executes a download of data, we create a timestamp record and assign it a DOI. The record contains information about the filters that were used for the query, which data sets contributed records, also an option to download the data as it was when the download was executed, and also to rerun the same query on the database as it is now. And then, of course, we ask any users of that particular data download to cite it by that DOI that we've assigned. When a specific download gets cited in a paper, which happens in nearly 40% of the cases now, the citations can be logged against the download and shown on the download landing page. But more importantly, we can use the metadata to unpack the citations to credit individual data sets and data publishers. And they are then able to assess how much their data is actually being used and for what purpose. So far, this has allowed us to identify and log more than 1,700 papers that cite specific GBIF data downloads and link those to the contributing data sets and publishers. In total, more than 12,000 downloads have been cited in journals. And while the uptake has been painstakingly slow, we're now seeing DOI cited in roughly about 1 in 3 citations of data from GBIF. Some challenges that we face include obviously when papers fail to cite a DOI, because then that makes it impossible for us to make the link between the paper and the specific data. This is often due to forgetfulness, and in most cases, these DOIs can be recovered, but there are also cases where there might not be a suitable DOI to cite. We often see that people don't trust filters, so they end up downloading way more data than they actually need, only to have to filter that data locally, which then leads to overcitation, as the download that they started out with contains significantly more data than they actually ended up using. Another example is when people access and analyze data directly in certain cloud computing environments. We share monthly snapshots to some of these environments, and they come with a DOI, but analyses often also filter this data significantly. So if you cite that DOI, you're also citing more than you're actually supposed to. And finally, to some extent, data from GBIF can also be accessed via synchronous API, meaning that people can extract data without us having a record of that data being extracted. So there's no DOI to cite. So in all these cases, users may definitely want to cite data appropriately, but they don't really have a good way of doing so. So we've come up with a new service as a solution to some of these problems that we're calling derived datasets. Derived datasets are intended to mimic what we do in terms of crediting data publishers for downloads, but for data that exists outside of a specific sort of download context. Put simply, we ask users to summarize data that they have accessed by the contributing datasets, and then provide us with a list of counts of records contributed by each of these. Ideally, they will also deposit this data set and provide us a link to where that filtered data can be accessed. Along with some basic information such as a title and a description, the user will then complete a form and will be given a DOI in return that they can use to cite that data. So from a metadata point of view, this new DOI will contain the same links as a proper download. So we will be able to unpack citations and credit individual data sets and publishers. And we like to think that this service will allow more flexibility in terms of how users access and analyze data, but still following, our citation guidelines and basically terms of use. And eventually, we of course hope to see a DOI in every single citation of GBIF data. And that's it for me. Thanks for listening.
Thank you, Daniel. You now win the prize for the shortest and most clear talk. You didn't try to put a 20-minute talk in your 8-minute talk. So thank you. Much appreciated. So on to Uwe, or Uwe. Sorry, I don't know the pronunciation of some of you.
Uwe, it's correct. I
Uwe.
need the screen. I cannot share. You have to release it.
Ah, yes, Daniel.
Okay. Sorry. So. Okay. Hi. Uwe Schindler here. I have also 8 minutes, but unfortunately, I have to present you something like 4 different types of collection data sets. So I have to hurry up a little bit, but I will do my best. So the first thing is I'm from Pangea. Most of you will know, so I will keep that very, very short. So Pangea is coming from the Earth and Environmental Sciences, and we have about 400,000 data sets with 19 billion data points and 3 petabytes of data. And there are a lot of data sets which are very, very similar, and often users are required to somehow download them as one entity and maybe also cite it as one entity because of the limitations, as said before. So we have some possibilities for people to create collections on our site. And we share them then with other services, including OpenAir, for example. So you can use them with what Paolo has shown before. And because of all the metadata, including relationships between our data sets, so our collections refer to the childs and vice versa, the OpenAir services by Scholix and Scholix can create a graph out of it. So, but now to the 4 collection types that we have. First of all, I wanted to say some things about a few terms which I'm using later, which is originality, threshold of originality, which is important because in the past, Pangea started to create collections of data sets, which are completely, just people wanted to have a collection out of some data sets which had nothing to do with each other, or the only thing they had was one publication. And the reason was people wanted to cite in one publication only one data set, which was okay at that time, but currently the publishers are changing. And we are now going more to group data sets by specific area. So one publication maybe cites 3 data sets, covering the 3 parts of the citation, 3 parts of the paper that was discussed there. So you have 3 data sets, each from a different scientific area. And so we don't want to have something like arbitrary collection, because there's no originality. The originality is only in the article, but not in the collection of data sets. And the other thing is, what is coming here is we have independent versus dependent publications. This affects the data sets itself, but also data sets which are part of collections. So, for example, if you have data which was solely published for an article, sometimes also called supplementary data set, then this is clearly a dependent publication, so it's not self-standing. But on the other hand, if you have a collection of several data sets which all cover the same theme, they can be grouped together, and the childs are dependent on the parent. So if somebody cites the parent, he automatically cites all the childs. But if he cites the child of the dataset, he also implicitly cites the parent, because there's a relationship from the child to the parent. So the standard Pangea dataset looks like that. I'm just showing that here. So that's a standard data set which has no real relationship. It has a citation. So looks like we know that. So people start now and want to cite multiple of those data sets in their publication. And so we get some different type of publication, which we call a publication series. I show an example of that because it really shows very, very well how it looks like. So we have here georeference photographs of benthic photo quadrants acquired for 160 transects distributed over 23 reefs. So this looks like all these data sets are looking more or less identical. Only the contents are slightly different. So that's a time series, for example. There it's different locations where the data was taken, but also different times. So all these data sets are looking identical, and we want to provide the users to download all of them in one part. And for that, we have also download as a zip file. So actually, the parent data set here, which is a collection, is itself a data set that you can download as one instance. But there are still people who want only cite a specific data set out of those, like the third one. And this is a child data set. So you can download that and use it. But if you cite it, you get something, because now we have a dependent publication. So it's dependent on its parent. So we have an in-citation, like you know from books. So somebody who cites the data set must only wants to cite that specific data set will automatically also use the parent. So in that case, the credit is going to the right people. So that makes it very, very easy for a lot of very, very similar data sets from a time series or whatever to be cited in one single DOI. Then we have something which is something we call a legacy of Pangea, which is called a bundled publication. So that means you have a data set, and the data set, you have a publication, and the publication refers to 3 different data sets and used those 3 data sets and created some new work out of it. It analyzed it, had some results out of it, and published the data sets in together. And the important thing is here, the data sets are not standing, cannot stand alone, because one child data set of the bundled publication is referring to, for example, an age model that you have in where you get the information in the depths in water, how old that part is. So that's for example the age model. But then you have another data set which relies on the age model, so you need to always download them together. And there's an example that that shows how it looks like. Here, for example, is a data set, pollen and diatom records of Lake Big Yarovö in Kalunda. And this consists of 3 data sets. Here we see, for example, the age-depth relation of the sediment core. You see some diatom records and pollen records. And each of those data sets included in that collection cannot live on its own. They rely on each other. And so we call this a bundled publication. It looks identical like before, so you also have an in citation. So you can still go and only cite the pollen and diatom records, but in general, you would always cite the parent of that publication. So the bundled publication, in our case, needs to have something like to have something like an originality. It needs to have some separate title. It needs to an abstract. It needs an abstract about how the different data sets are linked together, why they are published together, and in most cases, those data sets also have the same authors. So it's mostly a description about all the childs in general. So you have all the information you need to use the data sets.
Uwe,
yeah.
I know you're trying to give us a whole ton of information.
Yeah.
But I'm hoping you can wrap up relatively soon.
I'm wrapping up relatively fast.
Thank you.
Now. Okay. Yeah. So the next one is a little bit special. So I have now only the editorial publication, which is something going more in the direction that we have before. Seen before. It's something somebody is going and wants to put together some data sets and from different persons. So it's not his own data sets, it's just a collection of data sets about a specific purpose. He collected them and he makes something like a quality check that the data sets fit to each other and can put them together. And you can easily use them together. So he's the editor of that. And for that, we have an editorial collection. The data sets in the editorial collection are just arbitrary data sets. So you have a long description, you have citation with editors, and at the end, you have here all those data sets which can be used together. I'm already done.
Okay.
That's, yeah, unfortunately, it's really, it was really a lot of data sets. So give me half a minute. And so that's an editorial publication. And the last one that we have is just a bibliography, which is just a technical DUI, which is more like that we had before by the talks before, where you can just collect stuff together, get a common citation and a DOI to it, so you can refer to them as one single set, but there's no real intellectual thoughts behind that. It's just a collection that you can cite together in your publication, and that's we call just a bibliography. Looks identical, but we don't have editors on that. So that's that are the 4 types we have. And the first 2 ones are the most important ones to allow people to see the relationships between them and get the credit back to the authors of the original
thank you.
datasets.
Thank you, Uwe. If I could ask that you stop the share so we can have Martin go.
Yes, sorry.
Sorry, I realize I'm being a little militant, but I really want to get some discussion time in. I know we're having great discussion in the chat, but go ahead, Martin. You have to unmute. Martin, unmute. You're still muted. Shelley, do you have an ability to unmute? Oh, there you go.
I think I'm not a technical person, but I think I found the button. You can hear me now?
Yes, we can.
And I hope you can also see my slide. So what I said, nobody heard it, is that now I understand why I was the only one who has 2 presentations, and that's just a consolation prize, because I'm last and there's a lot of pressure on me already, keeping the time. But I think my slides are built to be brief, so I hope we can have a good discussion in 15 minutes or so. So the first part is about reliquaries at DataCite, or if we use DataCite, especially the DataCite metadata, how does this align with the proposed concept? And just as a reminder, and this was also a reminder for myself, this is how an actual reliquary looks like. This is from the Wikipedia page. To collect all your relics that I'm sure you all have at home, and there must be a place to put them. And of course, in this context today, we mean, and this is sort of verbatim from our document, this is sort of collections of objects which can be, and that's important, and we heard this several times, which can be data sets, but also other things, text, software, etc. And in DataCite, first we have a data set, and it's important that mainly because you can slice data sets in any way you want, and you saw this a little bit in the presentations by Uwe and Daniel. It's totally arbitrary, so a data set can be sort of basically a grouping of other data sets, etc., whether it's a time series or whatever. And in DataCite, we call a collection specifically something which is a heterogeneous collection, not just data sets. I don't think anybody is sort of policing that. So that in other words, the dataset resource type general collection is sort of very similar to Reliquary, and I will spend the next few minutes to see whether this is true with the proposed features, and also specifically discuss 2 points. And this is just to save some time. So this is the first 5 items in what a Reliquary should look like, and you just have to believe me because I want to save some time. This is all very possible with a DataCite collection, which means that it contains other content which itself has an identifier. You can describe the collection in itself. It's not just a bucket, but it also has metadata. And this is all sort of using control vocabularies and not just free text, etc. The first point I want to make is the statement about the reliquary appears in a reference section of a paper, and and then you can sort of cite subsets of a reliquary. And I think, while this is common mainly for books, which have a very natural structure with pages and chapters, for a collection of data sets, or let's say scholarly content, I think it's very hard and not natural to say I want to cite item 5 in the reliquary. And I think we would have to reinvent a lot of stuff that I'm personally not interested in, because it's just in terms of adoption and creating hurdles for people to do. So I would very much suggest that if you want to cite something that's a part of a reliquary, you cite that specific item. Each one of them has an identifier, whether it's a DOI or something else. If for some reason you want to do something special, and GBIF gave a good presentation where you basically need a dynamic data citation, meaning you create an identifier the moment you do the citation, because you decide to use a little bit of this data set plus this software, and then also this other data set, and then the RDA guidelines for doing dynamic citation align very well with this. This is about being able to specifically cite what you have used and not just stuff in this bucket. The other point I want to make is something where I first want to quickly go back to the 411 data citation principles, which obviously are more, but these are the two main reasons why we do data citation. And I always find it funny that the credit comes after the specificity and verifiability, but let's assume it's not in order. So there are two main reasons to cite data, and I think they're basically orthogonal. The first one is as broad as possible. The second one is as specific as possible, which means you always need more. You almost always will need more than one identifier if your data set becomes more complex, and with Reliquary, that's often the case. And for the point of citation credit, I would very much suggest that we focus on the Reliquary is the thing that we use to track citations for the purpose of credit, because every time somebody cites something in a Reliquary, it will always be the Reliquary. And obviously it's just a subset, but that is just the easiest way to do this. It's also what I said earlier about page numbers, it's also common practice in at least natural sciences, life sciences, environmental sciences. When you cite a journal article, nobody expects you to cite the method section or any subsection, but you just cite the paper. So it's also not specific, but it's something bigger. And here, I think that's a similar approach. Maybe Reliquary is bigger than a single publication, but it's just the idea. You want to make sure you don't lose anything. And that sort of credit is what it's about, that yes, you used some of this. And of course, in the long run, that's maybe unsatisfactory, that you want to be more fine-grained, but then you get into all these issues from versioning, contributor roles, and so forth. And I think if that's the goal at the beginning, you just can easily get stuck. And I think that's it for Reliquaries at DataCite.
So is that the end of your talk?
That's the end of my talk, but I have to give another talk.
No. Yeah.
If my computer doesn't explode because it feels really slow. And I should just go straight ahead, right?
Yes, please do.
Which is a very brief overview of make data count and sort of why it's important in this context. Make data count is an initiative that started a few years ago, I think 2014. That was when it was first grant funded by an NSF EAGE grant. And now it's sort of more than just the grant funded project, but it's more general, and there's people involved that are part of a grant or they just support this. Can you see the first slide?
Yes.
And again, because I want to try to do this in 5 minutes so that we are back in time for having enough time for discussion. It's super high level. The reason is mainly that there are some things that I think, or we think in Make Data Count often sort of get lost, and that sort of technical details, etc., that sort of better discussed elsewhere, whether it's the text document or longer presentations or workshops. So Make Data Count, as we sort of describe it now, is a community-led initiative focusing on the development of open research data assessment metrics. And we have some principles how we operate. transparency and accessibility is really critical. One question that I was reminded the other day actually in a Scholix session just last week is that research data assessment or data metrics is the goal of MDC and is not where we are now. And anybody who says elsewhere, I will just say you are either you have your own agenda, that's why you want to sell your data metrics, or you're just naive. I think realistically now or in the foreseeable future, I said 1 or 2 years, I mean, it's totally arbitrary. There's nothing that's close enough to seriously think about data assessment metrics that can be used for serious decisions about grant funding or researcher careers. So I hope that's clear to everyone. What it also means, of course, if there's nothing now, but we want and need this, then we have to start working on getting there. And that's what we should do now to make important decisions. For example, what I said in the previous slide, these metrics should be open and should be sort of support the community rather than providing a business opportunity. If I say this, then of course the next question is also very clear. Well, if that's not available now or soon, so how can I convince a single researcher that should invest any effort in data citation and making the data available, etc.? And I think that's a fair statement, but it also shouldn't mean that we just come up with some random metrics that don't mean anything, but they make the researcher feel better and incentivize him or her to sort of openly share their data. I think we have to be clear. The reason you should share data, and that's in general, or data social publication is very simply, that's good science. And if you just have a text description of some data that are hidden somewhere in a drawer, then as some people call it, it's an advertisement for science, but it's not science. And I think we should never forget this, that I think that's a good enough reason. If good science is not convincing, then I have sort of in the lower right corner, I have put the specific language that I also shared earlier, what the Joint Declaration of Data Citation says as principle number 7. That obviously, if you show the results of experiments and draw a conclusion, that if you cannot see the data and maybe have it do a deep look if you want to, then it's just not good science. And that's something that we're in a transition period, but I hope we get to this point where that's just how science is done. And I think that should be the driver for doing this, and not some metrics that I'm sure will evolve, but that are not existing today or in the very near future. Sorry. So, and I think that's the last slide to stay in time. If we say research data assessment metrics are not existing, but we hope to get there, what other things to consider? And I just picked 4, and there's probably 20 or more. And that would be a good sort of discussion topic, or we could do a whole breakout session on this. So something that you see all the time, if you provide incentives, this will make people do stuff they wouldn't do otherwise. And that's nice. But you should always be aware it's not sort of neutral objective, but metrics lead people to do certain things. And it will also unavoidable that they will do things that are undesired side effects. And one example that came to mind here is something called salami slicing, which is very common in publishing articles. But of course, with data, you can slice them in any way you want to, sort of to optimize your data metrics. Maybe you want to publish a data set that's a time series every year and get new credit for that if we come to that, etc. So So you're basically playing with fire if you come up with assessment metrics, and you should always be aware of this, which means, for example, there should be open community led and not come made by some commercial entity that decides what is a good data set. Something that we're actually working on right now in a Sloan funded grant is disciplinary context is super important. And the simple fact is just that some communities are much larger than others, or are sexier, or they cite more because that's what they do in these communities. And you should never compare a data set in social sciences with a data set in mathematics with a data set in environmental sciences. Sort of looking at the raw numbers. That's obvious, but that's sort of in journal article metrics, that's one of the biggest problems, that everybody knows this, but it's not really commonly practiced. What is also clear, and again, that's something we're working on right now in the Sloan grant, you need more than just counting beans. You need qualitative research to provide context for specific numbers, etc. And the last one is sort of to bring us back to Carol's presentation at the beginning. Citation practices are something really funny. And if you, for example, read an article and basically jump straight to the data because that's the stuff you're really interested in, you will still cite the article because that's what everybody's doing. So citation practices to map this, what people really tended to do, is tricky. And I would say the journal article right now is a bad research object because everything else is hidden, but it's basically the idea you cite the whole thing, and the article is just the most visible sort of tip of the iceberg. And then, in fact, what is really interesting is the data behind it, or even something else, just a new method that they developed. And with that, I stop. And I hope we have a little bit of time left for discussion.
Yeah, thank you so much, Martin. That was a great set of wrap-up talks in terms of all these points that have been brought up. So we have about 10 minutes left for discussion, and then we're going to save 5 minutes for sort of the wrap up. So there's been a great set of discussion in the chat, but I want to open it up for people to speak into the session and bring up points they particularly want, or observations from the set of talks. I know it can be a bit intimidating with this many people. If you're intimidated, then raise your hand and I'll call on you. And that will allow you to not feel quite as intimidated. But I'll call on you in a second, Shelley. So one observation I wanted to make is I think this was really a great set of talks to show some awesome examples of the pieces of this reliquary and the pitfalls and the positives of doing this. So thank you all as speakers. This was really a great tour de force of sort of what's out there. So Shelley.
I also reflect that appreciation. So we're looking at different stakeholders that are needed to make this work. So everything from tools that a researcher can use to either create their own reliquary, to work with a repository to do that directly, the journals, and then down the rest of the services from Crossref to DataCite to Scholix, and how does it all get counted? And our indexers are heavily engaged here. And then what does it mean to have done that? So let me start with the beginning. If I as a researcher would like to cite a couple hundred data sets, I figure out that this kind of reliquary exists. Do we have yet an example of me being able to do that on my own, or must I actually engage with a repository as my proxy? I think at the moment, I have to find a repository that will help.
Yeah, I think so.
Okay.
That is my experience as well.
Yeah.
Okay.
Yeah, so you could theoretically take a bibliography from our site or an editorial publication and create some data set. Unfortunately, at the moment, for us, it's currently limited to only Pangea data sets as childs. So that's another issue that you generally have if you want to cite a lot of data sets from different data centers, but we are extending to have something like that.
Wait, what? What?
To have to maybe have something like a collection where also foreign data sets can be included.
So that might be a future option. So
Yeah.
if we were going to try to do something today, we would be repository specific, but what you're saying is potentially in the future, especially if we have good use cases, in which I think we already do, that at least Pangea would be interested in adjusting to include outside other repositories.
Yeah.
That's very hopeful. Thank you.
Yeah. We have the possibility for that type of relationship already. So if you want to create a new data set and you want to refer to other data sets that you have used, you can do that already, but not for this really parent-child relationship. But that's more a technical issue.
Thank you.
All right, Carol.
Yeah, I was going to follow up to say at a different level in the stack, Shelley, that you can, and we do make citable RO crates that we talked about, which aren't actually in a repository, but then we can then put them into something like Zenodo. But you still need infrastructure. So I think the question here is, do you need a repository or do you need infrastructure? And those are two different questions. I think that's worth pulling those two things apart, because the user, somebody trying to make these citations, they need something in order to be able to form the object that they want to be able to act as the bagging object, as it were, for the different citations. So I think we do need, we should ask ourselves, what is the infrastructure that we need? And then what are the repositories that can also implement that kind of, or maybe use that kind of infrastructure, or that infrastructure could use? So to pull those two things apart, because I'm very keen that we think about, as what Joe has said, it works for, Pangea data, but we work in worlds where we want to be able to point to Pangea data and also point to data in GBIF, and also point to data in a workflow repository, because that's exactly what we're putting together in our specimen data refineries. It's all sorts of different things, and we want to point to all of that. And so one repository isn't enough. Does that make sense, Shelley?
It does, and I like the fact that you led us back to this combined type of outputs. We're running into at AGU, and I'm sure all of us here are hearing more about researchers being sharing enough of their outputs for replicability and reproducibility, and that really does require software and workflow and all of the other elements. So that is an important use case for how this could go. It doesn't mean it has to be the first iteration, right? So what RO Crate has done is very sophisticated.
But it's also not just the different kinds of objects, it's actually different kinds of data sets. Yeah. Held by different organizations, because of course research the researchers do sit in their own little disciplines, but many researchers are operating in multiple data set fields, and we have to honor the fact that we got some great data sets that are specialized, but we want to be able to point to things in each of them and allow them to be the special data sets that they are, but then to be able to talk about citing things across the collection. I think that's really important. I thought when Deb first presented this concept, the idea of spanning multiple repositories was absolutely critical, and I think we shouldn't forget that.
Yeah. So I see Martina Stockhouse is on. I'm not sure if she's able to participate in the conversation, but you know, thinking about what the IPCC needs, I mean, we've got all kinds of data types that go into those reports and those models, and you know, to be able to cite something, you know, important to that report, I can only imagine that the Reliquary or whatever it would be, whatever we decide to call it, would be significant. And it would, I would certainly want that use case to be part of what we're trying to do here.
Maybe I can add a couple of words to that. I think we have very different kinds of data. For some, it makes sense to have a reliquary, but if we have the large model data, which we cite as a homogeneous model run, and don't go so much into which data sets were used, maybe, no, let me rephrase it. So we have two things. One is giving credit, and the second is just specify which data sets underpin which figure. So we have the two problems here. One is that in these reliquaries, we have only parts of the data sets which are citable. So we have a subset, and then we bring together different runs, so very different data sets. Sometimes you compare it to reanalyzes. So there we have the different providers. Sometimes you have the other observation points in it. So yeah, it's really the use case for getting information on the data which went into figures. But in bringing it together, we are far from everything, because nearly all partners of the Data Distribution Center lost their funding due to the restrictions of the budget restrictions. So we just struggle to bring something together. So that's why I simply listen usually, but do not contribute actively to these important conversations. Thanks.
Thanks so much. So I think these are all really important points, and we do sort of have that chicken and egg problem, right? Do you start with the definition of the reliquary and the objects in it and how to cite it? Or do you start with the infrastructure that enables those things to have citation counts and all the other pieces? I think my leaning has been toward defining the reliquary and the pieces in it such that, because the feeling is then that the publishers would have something, some clarity of what to actually start to implement. The citation trackers would have a better idea of how to then track those citations and what they mean. So that's why the tendency to sort of focus on what is this reliquary collection bucket crate, whatever this thing is, because it's sort of around that. And I think these presentations have really given us an opportunity to think about that and to see it from different perspectives and different use cases and different ways they've been used to date. And they provide those stepping stones. And I think the next question is really, what are those next steps? What do we do from here? And I'd love to hear some opinions about what people would like to see from here. We've got about 3 minutes left, so I'd like to hear from a couple folks. Martin, I can see you're still unmuted, so I'm gonna call on you to see what you think might be the best next step.
I will say something that I have recently sort of resorted to a lot, which is use the simplest path. I think we all have a tendency to get very excited and sort of dream up systems that require so many pieces that have to interoperate that we end up getting stuck for 300, well, let's say for a few years before we do anything. So for example, what you said, to even agree on a term, Reliquary is, I think, intentionally a little bit unusual, and sort of pushing the concept, which is exactly what you're doing with this call and the last one. I think that's a good path. And then build around that, there's all kinds of nuance, but I think there's so much to build on already. We had several presentations today who have sort of implemented this concept, from biostudies to, is a good example. Yeah, so for me, that would be the guiding principle, to do something that we can do in 6 months, and not something where we first do 5 years of work and research and grants, etc.
So one thought that I've been sort of kicking around is maybe having a small working group of some of these use cases, and maybe it's the set of speakers that we had, where we try to talk through, could we come to some common agreement about what these properties look like, and then come together and propose something into this group again, or explain where the differences make it too hard, and sort of try to bring then to this group a beginning, at least, of what does it look like to start to utilize all this experience and all these existing capabilities to think about where do we go from here. Does that make sense to folks? Or
yeah, I think that's a great idea, Deb. And also, I really like Martin's point, which is, what is the least we need to do? So we're really like, could we actually identify the absolute minimum that's needed in order to be able to get something going that was grounded in real examples? And I think that's a really important thing, because we've got some things going on in other sectors, particularly in Europe, where theoretical stuff is coming out of people's heads, but it's impossible to build or use, and it has no use cases. We must keep things, what is the least we need to do, and what is the and that these really solve real problems. So I think it'll be a useful exercise to say, what have we got, and is there a project that would sponsor us to say, what have you got, and can we have a go at trying to put something together? Because you've got a lot of willing people here.
Right, and a fair number of desperate people who need something along this space, and are already trying to do something. And I consider that already the minimum criteria, because if people aren't desperate enough to be trying to do it, it's not actually as big a need as you thought. And you just heard from several people who are desperate. So we're out of time. Modulo, anybody having written anything in the notes document contradicting my plan, I think that's what we're going to move forward with, is trying to get this group together. People are welcome to volunteer themselves into that group. You don't have to have been a speaker, but I think we'll try to convene that smaller group to just try to see if we can narrow in on what makes sense as the solution. So thank you everybody. This has been fantastic, and really congrats to the speakers. Very nice collection of use cases and capabilities. So thank you.
Thank you, Deb and
Thank
Shelley
you.
and everybody else for organizing this. It's been really, really inspiring, actually.